Imagine this. Somewhere out there, in a universe much like ours, you made a different choice, one that led you to a life you can't even fathom. Welcome to the mind-bending world of the multiverse, where infinite versions of you might be living infinite versions of your life. This isn't just science fiction, it's a serious scientific theory that's captivating researchers and dreamers alike. So, are you ready to dive into the possibilities, embrace the wild speculation, and compare the unimaginable? Because once you start exploring the multiverse, there's no turning back. Let's get started. The fabric of reality, a cosmic tapestry. The multiverse theory, a mind-bending concept that has captivated scientists and science fiction enthusiasts alike, posits that our universe is but one in an infinite ensemble of universes. Each universe, with its own unique set of fields and interactions, could potentially give rise to different particles, forces, and even dimensions. This cosmic tapestry, woven with threads of infinite possibilities, is often referred to as the fabric of reality. In some universes, the laws of physics might be starkly different, allowing for phenomena that seem impossible in our own. For instance, in a universe with a stronger nuclear force, protons might be heavier, altering the periodic table and the very essence of chemistry. Conversely, a weaker force could result in a universe devoid of stars and galaxies, a stark contrast to our own cosmic landscape. The idea of parallel universes has been explored through various scientific lenses, including quantum mechanics and string theory. In the quantum realm, the many-worlds interpretation suggests that every quantum decision spawns a new universe, creating a vast multiverse where all possible outcomes of quantum measurements become real. This interpretation implies that there are universes where dinosaurs never went extinct, where you made different life choices, or where entirely different forms of life exist. Meanwhile, string theory proposes that our universe is just one of many vibrating strings in an 11-dimensional space, each string potentially giving rise to a different universe with its own unique properties. These theories, while speculative, offer intriguing glimpses into the nature of reality and the potential diversity of universes within the multiverse. Comparing different universes within the multiverse is a fascinating exercise in speculation. In some universes, the fundamental constants of nature might be slightly altered, leading to vastly different outcomes. For example, a universe with a higher value of the cosmological constant might expand too rapidly for galaxies to form, resulting in a cold, dark, and empty cosmos. In another universe, the strength of the electromagnetic force might be different, altering the behavior of atoms and molecules, and thus the very fabric of matter. These variations could lead to universes with exotic forms of life, unrecognizable physical laws, or even entirely different dimensions. The multiverse, in its infinite diversity, offers a canvas for exploring the full range of possibilities that nature can conjure. The birth of the multiverse theory. The concept of the multiverse, or the existence of infinite parallel universes, has been a subject of fascination and exploration in both scientific and philosophical circles. At its core, the multiverse theory suggests that our universe is just one in a vast array of universes, each with its own set of fields and interactions. This idea has been influenced by various scientific theories, including cosmic inflation, string theory, and quantum mechanics. Cosmic inflation, for instance, proposes that the universe underwent a rapid expansion shortly after the Big Bang. This expansion could have been uneven, leading to the formation of bubble universes with different physical constants. String theory, on the other hand, posits that the fundamental particles we observe are actually vibrations of tiny, one-dimensional strings. These strings can vibrate in different ways, potentially giving rise to different universes with distinct physical laws. Quantum mechanics also plays a significant role, with the many-worlds interpretation suggesting that every quantum possibility is realized in some universe. The birth of the multiverse theory can be traced back to these scientific explorations. Each theory offers a unique perspective on how parallel universes might come into existence. For example, cosmic inflation suggests that our universe is just one bubble in a vast cosmic ocean. These bubbles could have different temperatures, densities, and even different numbers of dimensions. String theory, meanwhile, envisions a vast landscape of possible universes, each corresponding to a different configuration of strings. These universes could have different forces, particles, and even different mathematical structures. Quantum mechanics, with its many worlds interpretation, proposes that every decision or event spawns a new universe. This means that there could be universes where you made different choices, where history unfolded differently, and where the laws of physics are slightly altered. Comparing these different universes is a fascinating exercise. In some universes, the fundamental constants might be slightly different, leading to variations in the strength of gravity, the speed of light, or the masses of elementary particles. These differences could result in vastly different physical landscapes. For instance, a universe with a stronger gravitational force might have planets that are denser and more compact. A universe with a different speed of light could have stars that burn hotter or cooler, altering the conditions for life. In other universes, the laws of physics might be entirely different. There could be universes where time flows backward, where there are extra dimensions, or where the fundamental forces are combined into a single force. These variations highlight the incredible diversity that the multiverse theory suggests. Speculation about these parallel universes is a natural extension of the multiverse theory. It's intriguing to consider that there might be universes where life evolved differently, where civilizations rose and fell under different stars, or where entirely different forms of intelligence exist. These universes could have different histories, different cultures, and different technological advancements. They might even have different forms of matter and energy, challenging our understanding of what is possible. The multiverse theory opens up a realm of possibilities, inviting us to explore the vast and varied landscapes that could exist beyond our own universe. It's a testament to the boundless nature of human curiosity and our relentless pursuit of understanding the cosmos. Quantum mechanics, the unseen threads. Quantum mechanics, the branch of physics dealing with the smallest particles in the universe, has long been a source of fascination and bewilderment. At its core, it introduces probabilities and uncertainties that challenge our everyday experiences. Electrons, for instance, don't orbit nuclei like tiny planets. Instead, they exist in a fuzzy cloud of probable locations. This fundamental strangeness is the unseen thread that weaves through the fabric of the multiverse theory. One of the most intriguing aspects of quantum mechanics is the concept of superposition. Particles can exist in multiple states or places at once until measured. Schrödinger's cat, a thought experiment, illustrates this perfectly. A cat in a box is both alive and dead until someone opens the box. This principle doesn't just apply to cats. It could imply that every quantum decision spawns a new universe. In one universe, the cat is alive. In another, it's dead. Each possibility plays out in its own separate reality. This idea, known as the many worlds interpretation, suggests that every quantum event branches off into a new universe, creating an ever-expanding multiverse. Comparing different universes in this framework leads to mind-bending possibilities. In some universes, slight variations in quantum events could lead to vastly different outcomes. For example, a tiny change in the quantum state of a single atom might alter the course of evolution, leading to entirely different life forms. In another universe, perhaps the Big Bang had slightly different conditions, resulting in a cosmos with different physical constants. These universes could have different laws of physics, different forms of matter, or even different dimensions. The sheer scale of these variations is staggering, making the multiverse a tapestry of infinite possibilities. Speculation about these parallel universes often involves comparing them to our own. Some might be almost identical, with only minor differences, while others could be radically different, defying our understanding of reality. In one universe, perhaps humanity never evolved, and intelligent dolphins rule the seas. In another, maybe technology advanced so rapidly that artificial intelligence took over eons ago. These comparisons highlight the vastness of the multiverse and the endless potential for variation. While we can't observe these universes directly, the implications of their existence are profound, pushing the boundaries of our understanding of reality and our place in it. Schrödinger's cat, a tale of two realities. Erwin Schrödinger's famous thought experiment, involving a cat that is simultaneously both alive and dead, has become a cornerstone of discussions about quantum mechanics and the multiverse theory. The scenario illustrates the principle of superposition, where a quantum system can exist in multiple states until it is observed. This idea has sparked endless debates and speculations about the nature of reality and the existence of parallel universes. In the context of the multiverse theory, Schrödinger's cat can be seen as a metaphor for the branching of realities. According to the many worlds interpretation, every quantum decision point spawns a new universe. So, in one universe, the cat is alive, and in another, it is dead. This interpretation suggests that all possible outcomes of quantum measurements become real in some universe. For instance, in one universe, you might have made a different career choice, while in another, you might have met a different life partner. The possibilities are endless, and each decision you make creates a new branch in the multiverse. Comparing different universes within this framework is a fascinating exercise. In some universes, the laws of physics might be slightly different, leading to vastly different outcomes. For example, in one universe, the cat might be a different species altogether, or the box might not exist at all. In another universe, the observer might be an alien species with entirely different sensory perceptions. These comparisons highlight the incredible diversity and complexity of the multiverse. They also raise intriguing questions about the nature of identity and consciousness. If there are infinite versions of you across the multiverse, which one is the real you? This question doesn't have a definitive answer, but it's a fun thought experiment to consider. Speculating about these parallel universes can be both thrilling and humbling. It challenges our understanding of reality and our place in the cosmos. While we may never have empirical evidence of these other universes, the idea that they exist offers a sense of infinite possibilities. It suggests that every choice, no matter how small, has profound implications. This perspective can be empowering, as it reminds us that our actions shape not just our own reality, but potentially countless others. It's a reminder to live consciously and make choices that align with our values and aspirations. After all, in some universe, you might be doing just that. The Many Worlds Interpretation. The Many Worlds Interpretation, MWI, of quantum mechanics, proposed by Hugh Everett III in the mid-20th century, suggests that all possible outcomes of quantum measurements become real in some world or universe. This interpretation implies that the universe is constantly splitting into a multitude of parallel universes, each representing a different possible outcome of quantum events. At the heart of MWI is the idea that the wave function, which describes the state of a quantum system, never collapses. Instead, all possible outcomes described by the wave function are realized in separate, non-communicating branches of the universe. In one of the most intriguing aspects of MWI, every decision you make causes a split. For instance, if you're deciding whether to have coffee or tea, the universe splits into two. In one universe, you choose coffee. In another, you choose tea. This idea extends to every quantum event, from the motion of particles to the behavior of entire galaxies. It's a mind-bending concept, but it's a natural consequence of taking the mathematics of quantum mechanics at face value. Some physicists argue that MWI is the most straightforward interpretation of quantum mechanics because it doesn't require any additional mechanisms, like wave function collapse, to explain quantum phenomena. Comparing different universes in the MWI framework is a fascinating exercise in speculation. In some universes, you might have made different life choices, leading to vastly different experiences and personal histories. In others, fundamental constants of physics might differ, leading to universes with different laws of nature. For example, the strength of the electromagnetic force could be slightly different, leading to a universe where atoms don't form as they do in ours. Or, the gravitational constant could vary, resulting in a universe with no stars or galaxies. These differences could be subtle or profound, but they all represent valid, existing branches of the multiverse according to MWI. The Many Worlds interpretation also raises intriguing questions about identity and consciousness. If every possible outcome is realized in some universe, then there are versions of you that have experienced every possible life path. This idea challenges our conventional notions of self and reality. It also opens up the possibility of communicating with other versions of ourselves, although this is purely speculative and currently beyond our technological capabilities. Despite its speculative nature, MWI has gained significant traction in the scientific community, with many physicists finding it appealing due to its simplicity and lack of anno domini hoc assumptions. However, it's important to note that MWI is still a topic of ongoing debate and research, and it's not yet universally accepted. Branching realities, a cosmic tree. The multiverse theory, particularly the idea of branching realities, suggests that every decision or event spawns a new universe, creating a vast, ever-growing cosmic tree. This concept, inspired by quantum mechanics, posits that all possible outcomes of quantum measurements become real in some branch of the universe. Picture a tree where each branch represents a universe, and every decision or event causes the trunk to split into new branches. In one universe, you might have taken a different job, while in another, you might have chosen a different path entirely. These branches are not mere hypotheticals. They are as real as the universe we inhabit, each with its own set of possibilities and realities. Consider the implications of this cosmic tree. In some branches, dinosaurs might never have gone extinct, while in others, humanity could have evolved differently. The laws of physics might vary slightly or drastically from one universe to another. In one branch, the constants of nature could be fine-tuned for life, while in another, they might be entirely inhospitable. The sheer scale of this idea is mind-boggling, as it suggests an infinite number of universes, each with its own history, present, and future. It's a humbling thought, realizing that our universe is just one tiny leaf on an enormous, ever-expanding tree. The concept of branching realities also raises intriguing questions about identity and existence. If every decision creates a new universe, then in some branches, you might be living a completely different life. You could be a scientist, an artist, or even someone entirely unrecognizable. This idea challenges our notions of self and destiny, suggesting that there are countless versions of you out there, each navigating their own unique path. It's a speculative notion, but one that invites deep reflection on the nature of reality and the choices we make. Moreover, the cosmic tree metaphor extends beyond individual decisions to encompass grander scales. Entire civilizations could branch off in different directions, leading to vastly different technological, cultural, and societal developments. In one universe, humanity might have colonized the stars, while in another, it might have remained confined to Earth. The possibilities are endless, and the implications are profound. This theory doesn't just expand our understanding of the cosmos, it redefines it, suggesting a multiverse that is far more complex and interconnected than we ever imagined. It's a reminder that reality is not a single, linear path, but a vast, branching tree of infinite possibilities. Inflationary cosmology, bubbles of existence. Inflationary cosmology suggests that the universe we inhabit is just one of many, perhaps infinitely many, bubbles of spacetime foam. This theory posits that during the early moments of the universe's existence, a rapid expansion, or inflation, occurred. This expansion wasn't uniform. Instead, it was a frothy, bubbling process. Each bubble represents a separate universe with its own unique properties and laws of physics. Our universe is just one of these bubbles, and others could be vastly different, with varying dimensions, forces, and constants. Some might not even have stars or planets, while others could be teeming with life forms we can't begin to comprehend. Consider the implications of these bubbles. In some universes, the gravitational constant might be stronger, leading to more massive stars and planets. In others, the electromagnetic force could be weaker, resulting in atoms that behave differently. The possibilities are staggering. Some universes might be devoid of matter entirely, existing as vast, empty voids. Others could have more than 4 dimensions, allowing for phenomena we can't even imagine. The diversity is as endless as the number of bubbles, each one a unique experiment in the grand multiverse. The concept of these bubbles isn't just theoretical whimsy. It's rooted in solid physics, particularly in the mathematics of eternal inflation. This theory suggests that once inflation starts, it never truly stops. It just keeps producing new bubbles, each with its own unique conditions. This process could be happening right now, all around us, invisible and undetectable. It's a humbling thought, realizing that our universe is just one among countless others, each with its own story to tell. Comparing these universes is a fascinating exercise. In our universe, the fine structure constant, which governs the strength of electromagnetic interactions, is about 1/137. But in another bubble, it could be different, leading to entirely different chemistry and physics. In some universes, the speed of light might not be constant, or gravity might behave differently. These variations could lead to universes where life as we know it is impossible, or where it thrives in forms we can't imagine. It's a cosmic lottery, and we're just one lucky ticket. Boltzmann brains and cosmic inflation. Cosmic inflation, a theory proposing that the universe underwent exponential expansion in its earliest moments, sets the stage for a mind-boggling array of possibilities. This rapid expansion, driven by a hypothetical field called the inflaton, could have given rise to a multitude of bubble universes, each with its own unique properties. These universes might differ in fundamental constants, such as the strength of gravity or the mass of elementary particles. In some, the laws of physics could be starkly different, allowing for phenomena that seem like magic in our universe. For instance, in one universe, the speed of light might be slower, making time travel to the past theoretically possible. In another, the strong nuclear force could be weaker, leading to a world where stars never form and galaxies remain dark and empty. Boltzmann brains, a concept derived from statistical mechanics, add another layer of strangeness to the multiverse. In an infinite universe, given enough time, random fluctuations could spontaneously generate self-aware entities, even in the absence of a complex evolutionary history. These hypothetical beings, dubbed Boltzmann brains, could arise from quantum fluctuations in the vacuum. In some universes, Boltzmann brains might outnumber biologically evolved life forms by an unfathomable margin. This raises profound questions about the nature of consciousness and the likelihood of our own existence. In a universe where Boltzmann brains are common, the probability of being one might be higher than being a product of biological evolution. This challenges our assumptions about reality and forces us to confront the possibility that our universe is just one of many, each with its own unique narrative. Comparing different universes within the multiverse reveals a staggering diversity of physical laws and constants. In some, the cosmological constant, which drives the accelerated expansion of our universe, could be negative, leading to a big crunch instead of a big freeze. In others, the fine structure constant, which governs the strength of electromagnetic interactions, could be different, altering the behavior of atoms and molecules. This could result in a world where chemistry as we know it is impossible, and life forms, if they exist, would be based on entirely different principles. In yet another universe, the gravitational constant could be stronger, leading to more massive stars and black holes, and a cosmos where galaxies form and evolve at a different pace. The implications of these differences are vast, suggesting that our universe is just one of many possible configurations, each with its own unique story to tell. The interplay between cosmic inflation and Boltzmann brains paints a picture of a multiverse that is both awe-inspiring and unsettling. In some universes, the conditions might be just right for the emergence of complex life, while in others, the laws of physics could be so alien that even the concept of life is meaningless. The existence of Boltzmann brains adds a layer of uncertainty, challenging our understanding of consciousness and reality. In a multiverse where anything that can happen does happen, the possibilities are truly endless. This raises profound questions about the nature of existence and our place in the cosmos. Are we alone? Or are there countless other beings, both biological and otherwise, scattered across the infinite landscape of the multiverse? The answers to these questions may forever remain beyond our reach, but the journey of exploration and discovery is an adventure in itself. String theory, vibrations of the multiverse. String theory proposes that the fundamental building blocks of the universe are not point-like particles, but rather one-dimensional strings that vibrate at different frequencies. These vibrations give rise to the various particles and forces we observe. When applied to the multiverse, This theory suggests that each universe could be a unique vibration pattern within a vast, interconnected cosmic landscape. The implications are staggering. Every possible variation of reality, every conceivable outcome, could exist somewhere in this grand symphony of strings. Consider a universe where the strong nuclear force is slightly weaker. Atoms might not form as we know them, leading to a cosmos filled with exotic matter and stranger stars. In another universe, the speed of light could be different, altering the very fabric of space-time. These variations are not just hypothetical musings. They are potential realities, each with its own set of physical laws and constants. The multiverse, in this context, becomes a vast tapestry of possibilities, each thread a different vibration of the fundamental strings. Comparing different universes within this framework reveals a fascinating interplay of similarities and differences. Some universes might be nearly identical to ours, with only minor variations in physical constants. Others could be radically different, with extra dimensions or entirely new forces. The concept of parallel universes, where every decision spawns a new reality, fits neatly into this model. Each choice, each quantum event, could be a new note in the cosmic symphony, branching off into an infinite number of universes. The idea of a multiverse filled with vibrating strings also raises profound questions about the nature of reality and our place within it. If every possible outcome exists somewhere, what does that mean for free will and determinism? Are we merely one note in an infinite cosmic melody, or is there something more to our existence? These questions push the boundaries of our understanding and challenge us to think beyond the confines of our own universe. The vibrations of the multiverse, in this sense, are not just a scientific concept, but a philosophical journey into the very essence of existence. M-theory, the 11th dimension. M-theory, a framework in theoretical physics, suggests the existence of 11 dimensions, with the first 10 being spatial and the 11th temporal. This 11th dimension is a mind-bending concept that proposes a vast, intricate structure to our universe. It's not just about length, width, and height, but also about other dimensions that could be compactified or hidden from our everyday perception. Think of it like this. If we consider our universe as a two-dimensional sheet of paper, the 11th dimension could be the third dimension that allows us to move through the paper, accessing different points without being confined to its surface. This dimension is crucial in M-theory as it allows for the existence of multiple universes, each with its own unique properties and physical laws. In the context of the multiverse, the 11th dimension could be the stage where different universes coexist. Each universe could be a distinct brane, short for membrane, floating in this higher dimensional space. These branes could be parallel to each other, almost like sheets of paper stacked in a book. In some versions of M-theory, these branes could even collide, potentially explaining events like the Big Bang. The possibilities are vast and speculative, but they open up intriguing avenues for exploration. For instance, in one universe, the laws of physics might be slightly different, leading to variations in the fundamental constants. In another, the arrangement of matter could be entirely distinct, perhaps even allowing for forms of life that are radically different from what we know. Comparing different universes in this framework is a fascinating exercise. Some universes might be incredibly similar to ours, with only minor differences in physical constants or historical events. Others could be vastly different, with alternate physical laws that defy our understanding. For example, a universe might exist where gravity is significantly stronger, leading to the formation of more massive planets and stars. In another, the strong nuclear force could be weaker, potentially preventing the formation of stable atoms. These variations could lead to universes that are unrecognizable, with entirely different forms of matter, energy, and even time. The 11th dimension, in this context, acts as a canvas where these diverse universes can exist, each with its own unique tapestry of physical laws and phenomena. Speculation about the 11th dimension and its implications for the multiverse is a hot topic in theoretical physics. Some scientists propose that these higher dimensions could be the key to unifying the fundamental forces of nature, providing a framework that encompasses everything from quantum mechanics to general relativity. Others suggest that the 11th dimension could be the gateway to other universes, allowing for the exchange of information or even travel between them. While these ideas are still firmly in the realm of speculation, they offer a tantalizing glimpse into the possibilities that lie beyond our current understanding of the universe. The 11th dimension, in this sense, is not just a mathematical construct, but a portal to a vast, unexplored cosmos. Holographic Principle, a universe on a screen. The holographic principle suggests that all the information contained within a volume of space can be described by the information on the boundary of that space. This mind-bending concept originates from the study of black holes and string theory, where it was observed that the information about objects falling into a black hole isn't lost, but is instead encoded on its event horizon. This principle has profound implications for our understanding of the universe and the multiverse. In a practical sense, the holographic principle implies that our three-dimensional universe could be a projection of information stored on a two-dimensional boundary. This boundary could be the cosmological horizon, the farthest point from which light can reach us. If this is true, then every universe within the multiverse could be a unique holographic projection, with its own set of physical laws and constants. Some universes might have different numbers of dimensions, while others could have varying fundamental forces. For instance, a universe might exist where gravity is stronger than electromagnetism, leading to vastly different structures and life forms. The idea of holographic universes opens up a realm of possibilities. In some universes, the speed of light might be slower, allowing for different technological advancements. Others might have different elementary particles, leading to unique forms of matter and energy. The holographic principle also suggests that these universes could be interconnected in ways we can't yet comprehend. Information might flow between them, or they might influence each other's evolution. For example, a universe with a higher dimensional boundary might have more complex structures and phenomena than ours. Moreover, the holographic principle challenges our notions of reality and consciousness. If our universe is a hologram, then what we perceive as reality might be a simplified, encoded version of a more complex, higher-dimensional reality. This could mean that consciousness itself is a holographic projection, raising questions about the nature of self and identity across the multiverse. Some theories even speculate that consciousness could be a fundamental aspect of the universe, with each universe in the multiverse having its own unique form of consciousness. This could lead to universes where life forms are vastly different from what we know, or where consciousness exists in forms we can't yet imagine. Simulated realities. Are we living in a simulation? The concept of simulated realities has been a staple in science fiction for decades, but it has also gained traction in philosophical and scientific circles. The idea posits that our universe, along with everything in it, could be an artificial construct, a simulation created by a highly advanced civilization. This notion is not as far-fetched as it might seem. Given the rapid advancements in technology, particularly in computing and virtual reality, it's not unreasonable to consider that future civilizations might have the capability to create incredibly detailed and convincing simulations. In fact, some argue that if such technology were to exist, it would be statistically more likely that we are living in a simulation rather than the base reality. One of the most compelling arguments for the simulation hypothesis comes from the field of computer science. As computing power increases, the ability to create complex, detailed simulations also increases. Today, we can create virtual worlds that are indistinguishable from reality in many aspects. Games like The Sims or Second Life offer environments where users can interact with objects and other users in ways that mimic real life. Extrapolating this trend into the future, it's plausible that a sufficiently advanced civilization could create a simulation so intricate that its inhabitants would be unable to distinguish it from reality. This idea is often referred to as the ancestor simulation theory, where a future civilization might run simulations of their ancestors to study history or explore hypothetical scenarios. Comparing different universes or simulations raises intriguing questions about the nature of reality and consciousness. If our universe is a simulation, it might be one of many, each with its own set of rules and parameters. These simulations could vary widely in their complexity and purpose. Some might be simple, designed for entertainment or educational purposes, while others could be highly complex, intended to explore philosophical or scientific questions. The idea of multiple simulations also opens up the possibility of interactions between them. For instance, glitches or anomalies in our reality could be signs of interactions with other simulations or the underlying code of our own. This concept is explored in various forms of media, such as the movie The Matrix or the TV series Rick and Morty, where characters encounter different realities with their own unique rules and characteristics. The simulation hypothesis also has implications for our understanding of physics and the laws of nature. If our universe is a simulation, then the physical laws we observe might be the result of programming choices made by the simulators. This could explain why certain constants, like the speed of light or the gravitational constant, have the values they do. It might also account for phenomena that are currently unexplained, such as quantum indeterminacy or the fine-tuning of the universe for life. Some physicists have even suggested that certain mathematical patterns or anomalies in our observations could be debugging artifacts left by the simulators. While these ideas are speculative, they highlight the potential for the simulation hypothesis to provide new insights into the fundamental nature of reality, parallel universes, and time travel. The multiverse theory, particularly the idea of parallel universes, has long captivated the imagination of scientists and science fiction enthusiasts alike. One of the most intriguing aspects of this theory is its potential intersection with time travel. In the realm of parallel universes, time travel isn't just about moving back and forth along a single timeline. It's about exploring the vast, branching paths of countless realities. Each decision, each event, no matter how small, could theoretically spawn a new universe, creating an infinite web of possibilities. This concept is often illustrated through the many-worlds interpretation of quantum mechanics, proposed by Hugh Everett III. In this interpretation, every quantum decision point branches into a multitude of universes, each representing a different outcome. Comparing different universes within this framework reveals a fascinating landscape. In one universe, you might have taken a different career path, while in another, you might have made vastly different life choices. These universes could diverge significantly from our own, with different historical events, technological advancements, or even fundamental physical laws. For instance, one universe might have advanced to a post-scarcity society, while another could be stuck in a technological dark age. The variations are endless, limited only by the laws of physics and the bounds of imagination. Time travel within this context would involve navigating these universes, perhaps even interacting with versions of yourself who have lived different lives. Speculation about time travel in parallel universes raises numerous questions. Could you change the past in one universe by traveling to it from another? Would the changes ripple through the multiverse, altering the course of history in multiple realities? Or would each universe remain isolated, preserving the integrity of its own timeline? Some theories suggest that any changes made in a parallel universe would only affect that specific branch, leaving other universes untouched. This idea is often explored in science fiction, where characters might jump between universes to undo mistakes or explore alternate versions of their lives. However, the practical implications of such travel remain purely theoretical, as our current understanding of physics does not yet support the technology required to make it a reality. The concept of parallel universes and time travel also invites us to consider the nature of identity and reality. If there are infinite versions of you living in different universes, which one is the real you? This question delves into the philosophical and existential aspects of the multiverse theory. It challenges our understanding of self and reality, prompting us to think about the fluidity of existence. In one universe, you might be a renowned scientist, while in another, you might be an artist or an adventurer. Each version of you is equally valid within the context of its own universe. This idea can be both liberating and unsettling, as it suggests that there are no definitive answers, only endless possibilities. The quantum multiverse, a labyrinth of possibilities. The quantum multiverse is a mind-bending concept that emerges from the depths of quantum mechanics, suggesting that every possible outcome of a quantum event spawns a new, parallel universe. This idea, often referred to as the many-worlds interpretation, was first proposed by Hugh Everett III in the mid-20th century. At its core, it posits that all possible alternative histories and futures are real, each representing an actual world in a vast, ever-branching multiverse. For instance, every time you make a decision, the universe splits, creating a new reality where each possible choice becomes manifest. This means that somewhere out there, there's a version of you who made a different choice, leading to an entirely different life. Consider the humble electron. In our universe, it might be spinning up, but in another universe, it's spinning down. This seemingly small difference can have vast implications. In one universe, this might lead to a slight variation in a chemical reaction, which could alter the course of evolution. In another, it might trigger a chain reaction that results in a completely different planetary system. The possibilities are as vast as they are unpredictable. It's like a cosmic game of choose-your-own-adventure, where every choice, no matter how small, leads to a new story. Now, let's compare a few of these universes. In one, perhaps the dinosaurs never went extinct, leading to a world where humans never evolved. In another, maybe the Roman Empire never fell, resulting in a society that blends ancient and modern technologies in ways we can't even imagine. Or consider a universe where the laws of physics are slightly different. Maybe gravity is stronger, leading to planets with immense gravitational pulls, or weaker, resulting in worlds where life floats freely. In some universes, the speed of light might be different, altering the very fabric of space and time. The diversity is staggering, limited only by the laws of physics as we understand them. Speculation runs wild when considering the implications of the quantum multiverse. Some theories suggest that these parallel universes might interact with each other in subtle ways, explaining phenomena like quantum entanglement. Others propose that advanced civilizations might one day find a way to communicate or even travel between these universes. It's a labyrinth of possibilities, each one a thread in an intricate cosmic tapestry. While we may never have definitive proof, the idea alone is a testament to the boundless nature of reality and the endless potential that lies within it. Dark matter and the multiverse. Dark matter, an invisible and mysterious substance, makes up about 27% of the universe's total mass and energy. It doesn't emit, absorb, or reflect light, making it undetectable by conventional means. Yet, its presence is inferred through gravitational effects on visible matter, like stars and galaxies. In the context of the multiverse theory, dark matter takes on an even more intriguing role. Different universes within the multiverse could have varying amounts and types of dark matter, leading to vastly different cosmic structures and evolutionary paths. For instance, a universe with a higher concentration of dark matter might have galaxies that are more densely packed, while one with less could have sparse, scattered star systems. Speculation about dark matter's role in the multiverse opens up fascinating possibilities. Some theories suggest that dark matter could facilitate interactions between universes. In these scenarios, dark matter might act as a bridge, allowing energy or even information to pass between parallel worlds. Alternatively, dark matter could be unique to each universe, with different properties and behaviors in each. This could mean that the laws of physics as we know them might not apply universally, and each universe could have its own distinct set of fundamental forces and constants. For example, a universe with a different type of dark matter might have altered gravitational interactions, leading to entirely different planetary systems and life forms. Comparing different universes based on their dark matter content is a complex but intriguing exercise. In our universe, dark matter's gravitational pull helps bind galaxies together and influences the large-scale structure of the cosmos. In another universe, if dark matter were more abundant, galaxies might form earlier and more rapidly, potentially leading to a universe that is more densely populated with stars and planets. Conversely, a universe with less dark matter might have a more leisurely pace of galaxy formation, resulting in a sparser cosmic landscape. These differences could have profound implications for the evolution of life, as the abundance and distribution of dark matter could directly impact the conditions necessary for habitable planets to form. The multiverse theory also invites us to consider the possibility of universes with no dark matter at all. In such a scenario, the cosmic structure would be dramatically different. Without the gravitational influence of dark matter, galaxies might not form as we know them, leading to a universe filled with isolated star systems or even a vast, empty void. This stark contrast highlights the crucial role that dark matter plays in shaping the universe we observe. It also underscores the vast diversity that could exist within the multiverse, with each universe potentially offering a unique cosmic tapestry shaped by its own dark matter dynamics. Dark energy, the cosmic accelerator. Dark energy, a mysterious and pervasive force, is the driving mechanism behind the accelerated expansion of our universe. It constitutes approximately 68% of the universe's total energy density, yet its nature remains one of the most profound mysteries in cosmology. The discovery of dark energy's influence on the universe's expansion rate was a monumental shift in our understanding of cosmic dynamics. It suggests that our universe is not only expanding, but doing so at an ever-increasing pace. This acceleration implies that galaxies are moving away from each other at a rate that grows over time, a phenomenon that challenges our conventional understanding of gravity and the cosmos. In the context of the multiverse theory, dark energy's role becomes even more intriguing. Different universes within the multiverse could have varying amounts and types of dark energy, leading to vastly different cosmic landscapes. For instance, a universe with significantly more dark energy than ours might expand so rapidly that galaxies and stars couldn't form, resulting in a cold, dark, and empty cosmos. Conversely, a universe with less dark energy might collapse under its own gravity, leading to a big crunch scenario. These variations highlight the diversity of possible universes and the critical role that dark energy plays in shaping them. Speculation about the nature of dark energy opens up a realm of possibilities. Some theories suggest that dark energy could be a property of space itself, a kind of energy associated with the vacuum of space. This idea, known as the cosmological constant, was first proposed by Albert Einstein. In other universes, this constant might take on different values, altering the fundamental properties of space and time. For example, a universe with a higher cosmological constant might experience faster expansion, while one with a lower constant might expand more slowly or even contract. These differences could lead to universes with unique physical laws and constants, making them vastly different from our own. Comparing different universes based on their dark energy content is a fascinating exercise. In our universe, dark energy's density is relatively low, allowing for the formation of structures like galaxies and stars. This balance is crucial for the existence of life as we know it. In other universes, the balance might be tipped differently. A universe with slightly more dark energy could still support life, but the galaxies might be more sparsely distributed. On the other hand, a universe with significantly less dark energy might have a denser distribution of galaxies, leading to more frequent cosmic collisions and a more chaotic cosmic environment. These comparisons underscore the delicate balance that allows for the existence of life and the diversity of possible cosmic scenarios. Black holes, gateways to other realms. Black holes, those enigmatic cosmic entities, have long captivated the imagination of scientists and science fiction enthusiasts alike. Their immense gravitational pull warps space-time, creating a boundary known as the event horizon, beyond which nothing, not even light, can escape. This phenomenon has led to intriguing speculations about their role in the multiverse theory, particularly as potential gateways to other realms. One compelling idea is that black holes could serve as portals to other universes within the multiverse. According to this hypothesis, the extreme conditions near the singularity at the center of a black hole might create a bridge to another universe. This concept is rooted in the idea of wormholes, hypothetical tunnels through space-time that could connect distant points or even different universes. While wormholes remain purely theoretical, The notion that black holes could act as natural wormholes is a fascinating avenue of exploration. Different universes within the multiverse could vary dramatically in their physical laws and constants. For instance, one universe might have a stronger gravitational force, while another could have different fundamental particles. These variations could lead to vastly different structures and phenomena. In some universes, the laws of physics might be so alien that life as we know it could not exist. In others, the conditions might be remarkably similar to our own, with subtle differences that could have profound implications for the evolution of life and civilizations. Speculation about the nature of these other realms often involves comparing them to our own universe. Some theories suggest that parallel universes could be exact copies of ours, with slight variations in events or individual choices. Others propose that these universes could be entirely distinct, with their own unique histories, species, and technologies. The idea that black holes could be gateways to such diverse realms adds a layer of complexity to our understanding of the cosmos. It challenges us to consider the possibility that our universe is just one of many, each with its own set of physical laws and realities. This perspective not only expands our scientific horizons, but also invites us to ponder the deeper philosophical implications of a multiverse. Wormholes, cosmic shortcuts. Wormholes, also known as Einstein-Rosen bridges, are hypothetical tunnels in space-time that could create shortcuts for long journeys across the universe. These theoretical passages are predicated on the mathematics of general relativity, which allows for the existence of such structures. In essence, a wormhole connects two separate points in space-time, potentially enabling travel between distant regions of the universe or even between different universes. The concept is derived from the idea that space-time can be warped and twisted, much like a piece of paper can be folded to bring two distant points closer together. This warping could, in theory, create a tunnel with two ends at separate points in space-time. The idea of wormholes opens up fascinating possibilities for interstellar and interuniversal travel. If stable wormholes exist, they could serve as cosmic shortcuts, drastically reducing travel time between distant stars or galaxies. For instance, a wormhole could connect our solar system to a distant exoplanet, allowing for almost instantaneous travel. This would revolutionize space exploration and potentially facilitate the colonization of other worlds. Additionally, wormholes could provide a means to explore other universes within the multiverse. Each universe might have its own unique physical laws, constants, and even forms of life. Traversing a wormhole could offer a glimpse into these alternate realities, revealing vastly different versions of physics and existence. However, the practicality of wormholes remains speculative. One of the primary challenges is the stability of these structures. Wormholes are notoriously unstable and tend to collapse almost instantly, making them unusable for travel. To keep the wormhole open, exotic matter with negative energy would be required, a substance that has not been observed in nature and whose existence is purely theoretical. Furthermore, the energy requirements to create and maintain a wormhole are astronomically high, far beyond our current technological capabilities. Even if these challenges could be overcome, navigating a wormhole would be fraught with dangers, including the potential for spaghettification, where tidal forces stretch and compress matter into a thin strand, and the risk of encountering unknown phenomena within the wormhole itself. Despite these hurdles, the concept of wormholes continues to captivate scientists and science fiction enthusiasts alike. In popular culture, wormholes often serve as plot devices for time travel and interstellar adventures. Shows like Star Trek and movies like Interstellar have popularized the idea of using wormholes to traverse vast cosmic distances. These portrayals, while often exaggerated, highlight the potential of wormholes to reshape our understanding of the universe. In a multiverse scenario, wormholes could act as gateways to parallel universes, each with its own unique history, evolution, and inhabitants. Exploring these universes could provide insights into the fundamental nature of reality and the infinite possibilities that exist beyond our own cosmos. The Fermi Paradox, are we alone? The Fermi Paradox is a high-concept question that has baffled scientists and enthusiasts alike. If the universe is teeming with potentially habitable planets, why haven't we found any signs of extraterrestrial intelligence? This paradox is named after physicist Enrico Fermi, who famously posed the question during a lunchtime conversation with colleagues in the 1950s. The paradox is based on the apparent contradiction between the high estimates of the probability of the existence of extraterrestrial civilizations and the lack of contact or evidence for such civilizations. It's a head-scratcher, to say the least. One of the key factors in the Fermi paradox is the sheer scale of the universe. There are an estimated 2 trillion galaxies in the observable universe, each containing hundreds of billions of stars. With so many stars, it's reasonable to assume that there are countless planets orbiting them. In fact, the Kepler Space Telescope has already identified over 40 exoplanets, with many more waiting to be discovered. Some of these planets are located in the habitable zone, where conditions might be just right for life as we know it to exist. Yet, despite these promising numbers, we have yet to find definitive evidence of extraterrestrial life. The multiverse theory adds another layer of complexity to the Fermi paradox. This theory suggests that our universe is just one of many, each with its own set of physical laws and constants. In some universes, life might be abundant and thriving, while in others, it might be rare or non-existent. The multiverse theory is still purely speculative, but it's an intriguing idea that could help explain the Fermi paradox. If life is rare in our universe, it might be common in others, and vice versa. It's a humbling thought, but it's also a reminder of how much we still have to learn about the cosmos. Another possibility is that extraterrestrial civilizations are simply too far away for us to detect. The universe is unimaginably vast, and signals can take thousands or even millions of years to travel such distances. It's possible that we're not alone, but we're just too isolated to know it. Alternatively, perhaps advanced civilizations have found a way to communicate or travel between universes, leaving ours behind. It's a chilling thought, but one that's worth considering. After all, the Fermi paradox is a reminder that the universe is full of mysteries, and we're only just beginning to scratch the surface. The Anthropic Principle, a fine-tuned universe. The Anthropic Principle suggests that the universe's fundamental constants are fine-tuned to allow for the existence of intelligent life. This idea is not just a philosophical musing, but a scientific observation. For instance, the cosmological constant, which represents the energy density of empty space, is so finely balanced that even a slight alteration would have catastrophic consequences. If it were larger, the universe would have expanded too rapidly for galaxies to form. If smaller, it might have collapsed before stars could ignite. This delicate balance hints at a universe tailored for life, a concept that has sparked intense debate and speculation. In the context of the multiverse theory, the Anthropic Principle takes on an even more intriguing dimension. If our universe is just one among an infinite number of parallel universes, each with its own set of physical constants, then the existence of life in our universe is not particularly surprising. It's akin to finding a needle in a haystack, but with an infinite number of haystacks, it's inevitable that at least one will contain a needle. Other universes might have vastly different properties, making them inhospitable to life as we know it. For example, a universe with a stronger nuclear force might have no hydrogen, the most abundant element in our universe, rendering life impossible. Conversely, a universe with a weaker gravitational force might never form stars and planets, leaving it a cold, dark void. The implications of the Anthropic Principle extend beyond mere speculation. It challenges our understanding of the universe and our place within it. Some scientists argue that the principle is a testament to the power of natural selection, with life adapting to the conditions of our fine-tuned universe. Others see it as evidence of a deeper, underlying design, though this interpretation is more philosophical than scientific. Regardless of one's stance, the principle underscores the remarkable nature of our universe and the delicate balance that allows for our existence. It also opens up fascinating avenues for exploration, as scientists strive to understand the fundamental laws that govern our reality and the possibilities that lie beyond. Multiverse and the nature of consciousness. The concept of the multiverse suggests that our universe is just one in an infinite number of universes, each with its own unique set of physical laws and constants. This idea opens up fascinating possibilities for the nature of consciousness. In some universes, consciousness might be a fundamental property of the cosmos, woven into the fabric of reality itself. In others, it could be an emergent phenomenon, arising from complex systems like brains or even advanced artificial intelligence. The variations are endless, and each universe could present a different answer to the age-old question of what consciousness truly is. Consider a universe where the fundamental constants are slightly different. In such a place, the structure of atoms might vary, leading to different forms of matter and energy. Consciousness, if it exists there, could be tied to entirely different biological or even non-biological processes. For instance, in a universe with stronger electromagnetic forces, life might be based on silicon rather than carbon. The consciousness of silicon-based life forms would likely be vastly different from our own, perhaps more interconnected or more fragmented. These differences highlight how the nature of consciousness is deeply tied to the physical laws governing each universe. In another universe, the laws of physics might allow for multiple forms of consciousness to coexist. Perhaps there are beings made of dark matter, experiencing reality in ways incomprehensible to us. Their consciousness could be based on entirely different sensory inputs and cognitive processes. Alternatively, in a universe where quantum mechanics plays a more dominant role, consciousness might be a collective phenomenon, shared among all entities in a vast, interconnected web. This idea challenges our understanding of individuality and self-awareness, suggesting that in some universes, the boundaries between selves might be far more fluid. The multiverse theory also raises intriguing questions about the evolution of consciousness. In some universes, consciousness might have evolved much earlier or later than it did in ours. In others, it might not have evolved at all, leaving those universes devoid of any sentient beings. The diversity of possible evolutionary paths means that consciousness could take on countless forms, each shaped by the unique conditions of its universe. This speculation underscores the idea that consciousness is not a fixed or universal phenomenon, but rather a dynamic and adaptable one, capable of manifesting in countless ways across the multiverse. The holographic multiverse, a cosmic illusion. The holographic principle, initially proposed by theoretical physicist Gerard T. Hooft and later expanded by Leonard Susskind, suggests that all the information contained within a volume of space can be described by the information on the boundary of that space. This principle has profound implications for our understanding of the universe and has led to the intriguing concept of the holographic multiverse. In this scenario, our three-dimensional universe might be a mere projection of information encoded on a two-dimensional boundary, much like a hologram. This idea challenges our perceptions of reality and opens up a realm of possibilities where multiple universes could coexist, each a unique interpretation of the same underlying data. Consider the implications of this theory. If our universe is indeed a hologram, then the multiverse could be a vast collection of two-dimensional information structures, each giving rise to a different three-dimensional reality. These universes might differ in fundamental ways, with varying physical constants, laws of nature, or even dimensions. Some could be barren and lifeless, while others might teem with diverse forms of life, vastly different from what we know. The holographic multiverse suggests that these universes are not separate entities, but rather different projections of the same cosmic information, like different images encoded on the same holographic plate. Comparing different universes in this framework becomes a fascinating exercise in speculation. In one universe, the force of gravity might be stronger, leading to the formation of more massive planets and stars. In another, the speed of light could be different, altering the very fabric of space-time. Some universes might have extra dimensions, while others could be confined to just two. The holographic principle allows for an almost infinite variety of universes, each with its own unique set of physical laws and constants. This diversity is not random, but arises from the different ways information can be encoded and interpreted on the cosmic boundary. The holographic multiverse also raises questions about the nature of consciousness and reality. If our universe is a projection, what does that mean for our perception of the world? Could consciousness itself be a holographic construct? These are deep and complex questions that challenge our understanding of existence. The holographic multiverse theory is still speculative, but it offers a compelling framework for exploring the nature of reality and the possibility of multiple universes. As our understanding of quantum physics and information theory continues to evolve, so too will our grasp of the holographic multiverse and its implications for our place in the cosmos. The multiverse and the end of time. The multiverse theory, a concept that has captivated both scientists and science fiction enthusiasts alike, posits the existence of infinite parallel universes. Each of these universes could potentially host different versions of reality, with varying histories, presents, and futures. The idea is not just a flight of fancy, but is grounded in serious scientific exploration, particularly in the fields of quantum mechanics and cosmology. One of the most intriguing aspects of this theory is the concept of the end of time within these universes. Time, as we understand it, is a fundamental dimension that governs the sequence of events. However, in a multiverse, the nature of time could be radically different. In some parallel universes, time might not exist as a linear progression, but could be a loop, a branching tree, or even a static entity. This raises fascinating questions about the end of time. In our universe, the end of time is often associated with the heat death of the universe, a scenario where the universe has reached a state of maximum entropy. But in other universes, the end of time could be entirely different. For instance, in a universe where time is cyclic, the end of one cycle could mark the beginning of another, creating an eternal cycle of creation and destruction. This cyclical nature of time could mean that there is no true end, just an endless series of beginnings and endings. Comparing different universes within the multiverse framework allows for a rich tapestry of possibilities. In some universes, the laws of physics might be slightly different, leading to variations in the fundamental constants of nature. These differences could result in universes where time flows at a different rate or where the concept of time is entirely alien to our understanding. For example, in a universe with a higher gravitational constant, time might pass more slowly compared to our universe. Conversely, in a universe with a lower gravitational constant, time could pass more quickly. These variations could have profound implications for the existence and perception of time within each universe. Speculation about the multiverse and the end of time also extends to the nature of consciousness and existence. In some universes, consciousness might be a transient phenomenon, existing only for a brief moment before the universe reaches its end. In others, consciousness could be eternal, transcending the boundaries of time and space. This raises profound questions about the nature of reality and our place within it. The multiverse theory, with its infinite possibilities, challenges our understanding of time, existence, and the very fabric of reality. It invites us to explore the boundaries of our knowledge and to consider the vast, uncharted territories that lie beyond our current comprehension. The multiverse, a philosophical perspective. The multiverse theory, with its mind-bending implications, has long been a playground for philosophers. It's not just a scientific concept. It's a philosophical goldmine that challenges our understanding of reality, identity, and existence. At its core, the multiverse suggests that our universe is just one in a vast ensemble of universes, each with its own set of fields and interactions, and possibly even different constants of nature. This idea opens up a Pandora's box of philosophical questions. For instance, if there are infinite universes, does that mean every possible outcome of every event actually occurs somewhere? This is known as the many-worlds interpretation, a branch of the multiverse theory that posits that all possible alternate histories and futures are real and exist in some world or universe. Consider a simple decision, like choosing between tea or coffee. In one universe, you chose tea, and in another, you chose coffee. This idea isn't just about personal choices, though. It could extend to larger, more complex events. In one universe, the dinosaurs might have never gone extinct. In another, perhaps humanity never evolved. These universes could have vastly different physical laws, different forms of life, or even different dimensions. The philosophical implications are staggering. It challenges the notion of a single, objective reality. If every possible outcome occurs in some universe, then what does that mean for concepts like fate, free will, and determinism? Moreover, the multiverse theory invites us to ponder the nature of identity. If there are infinite versions of you, each making different choices, which one is the real you? This is a question that delves into the heart of personal identity and consciousness. It's a topic that has been explored in various forms of media, from literature to film, often to thought-provoking effect. For example, in the philosophical thought experiment known as the ship of Theseus, if every part of a ship is replaced over time, is it still the same ship? Applying this to the multiverse, if there are infinite versions of you, each with slightly different experiences and memories, at what point do you become a different person? The multiverse also raises questions about the nature of existence itself. If there are infinite universes, does that mean that existence is inherently probabilistic? It's a concept that blurs the line between science and philosophy, between the tangible and the abstract. It's a topic that invites speculation, debate, and introspection. It's a reminder that the universe, and our understanding of it, is far more complex and mysterious than we often give it credit for. It's a challenge to our perceptions, our beliefs, and our understanding of reality. And perhaps, in the end, that's what makes the multiverse theory so fascinating. It's not just a scientific concept. It's a philosophical journey into the very nature of existence. The multiverse, a scientific frontier. The concept of the multiverse, once relegated to the realm of science fiction, has gained significant traction in scientific circles. It posits that our universe is but one in an infinite ensemble of universes, each with its own set of fields and interactions. This idea is not merely philosophical musing. It is grounded in theoretical physics, particularly in the framework of eternal inflation. In this model, the universe we observe is just one of many bubble universes, each with its own unique properties and physical laws. The implications are staggering, suggesting that somewhere out there could be universes where the fundamental constants are different, where life evolves along entirely different paths, or where the very fabric of reality is structured in ways we can scarcely comprehend. Comparing these universes is a fascinating exercise in speculation. In some, the gravitational constant might be stronger, leading to more compact galaxies and stars. In others, the electromagnetic force could be weaker, resulting in vastly different atomic structures and, consequently, different forms of chemistry and biology. The possibilities are endless, and each variation opens up new avenues for exploration. For instance, a universe with a higher speed of light would have different cosmic structures and perhaps even different laws of physics. The diversity is not just limited to physical constants. Entire dimensions could be added or subtracted, altering the very nature of space and time. This comparative approach helps scientists understand the fundamental parameters that make our universe habitable and unique. The multiverse theory also raises profound questions about the nature of reality and our place within it. If there are indeed infinite universes, then every possible outcome of every event could be playing out somewhere. This includes versions of ourselves making different choices, leading to entirely different lives. The idea of parallel selves is a compelling thought experiment, blurring the lines between science and philosophy. It challenges our understanding of identity, causality, and free will. Moreover, the multiverse hypothesis could potentially explain some of the fine-tuning observed in our universe. If there are countless universes with different physical laws, it's not surprising that we find ourselves in one that is conducive to life. This anthropic principle suggests that our existence is a natural consequence of the multiverse's vast diversity. Speculation about the multiverse extends beyond theoretical physics. It has inspired countless works of fiction, from parallel world narratives to alternate history scenarios. These stories explore the implications of a multiverse in a way that pure science cannot, delving into the emotional and existential aspects of infinite realities. They often pose questions about what it means to be human in a universe that is just one of many. While these narratives are not scientific, they contribute to the cultural dialogue around the multiverse, making it a more accessible and relatable concept. The interplay between science and fiction in this area is a testament to the human fascination with the unknown and the desire to understand our place in the cosmos. The future of multiverse research. The concept of the multiverse has evolved from a speculative idea to a serious area of scientific inquiry. Physicists and cosmologists are now actively exploring the possibilities of parallel universes, driven by advancements in quantum mechanics and cosmology. One of the most compelling aspects of this research is the idea that each universe could have its own unique set of physical laws and constants. For instance, in one universe, the force of gravity might be stronger, leading to vastly different planetary formations and life forms. In another, the speed of light could be slower, altering the very fabric of space and time. These variations open up a vast landscape of possibilities, each with its own unique characteristics and potential for life. The future of multiverse research is likely to focus on developing new theoretical frameworks and experimental techniques to detect and study these parallel universes. One promising avenue is the use of quantum computing, which could simulate complex multiverse scenarios and provide insights into the nature of reality. Additionally, advancements in particle physics, such as the development of more powerful colliders, could reveal signatures of interactions between our universe and others. For example, anomalies in the cosmic microwave background radiation or unexpected particle behaviors could hint at the existence of other universes. The comparison of these universes could lead to groundbreaking discoveries, such as understanding why our universe has the specific constants it does, or even finding evidence of life in other universes. Speculation about the nature of these parallel universes is both thrilling and humbling. In some universes, life might be vastly different from what we know, with creatures adapted to extreme conditions or entirely different biochemical processes. For example, a universe with a higher concentration of heavy elements could have life forms with more complex molecular structures. In others, the laws of physics might be so different that life as we know it could not exist. These comparisons not only expand our understanding of the cosmos, but also challenge our perceptions of what is possible. The future of multiverse research holds the potential to answer some of the most profound questions about our existence and our place in the grand tapestry of reality. As we wrap up our journey through the mind-bending landscape of the multiverse, let's take a moment to recap the key points that have blown our minds. We've explored the idea that our universe might be just one in an infinite number of bubbles, each with its own unique set of physical laws and constants. We've delved into the many worlds interpretation, where every decision we make spawns a new universe, a new reality where things played out differently. And we've pondered the holographic principle, which suggests that our entire universe might be a projection from a two-dimensional boundary. But what does this mean for us, here in our little corner of the cosmos? Well, it's a lot to take in, isn't it? It's like standing on the shore of an infinite ocean, gazing out at the horizon and realizing that there's so much more out there than we could ever imagine. It's humbling, it's exhilarating, and it's a little bit terrifying. So what's next? Where do we go from here? Well, that's up to you. The multiverse is a vast and uncharted territory, and there's no telling what we might find if we dare to venture forth. Maybe you'll find yourself drawn to the many worlds interpretation, exploring the endless possibilities of alternate realities. Or perhaps you'll be captivated by the holographic principle, seeking to unravel the mysteries of our universe's two-dimensional boundary. Whatever your path, know that you're not alone. There's a whole community of explorers out there, ready to journey with you into the unknown. And speaking of journeys, we've got some exciting ones lined up for you here. In our next video, we'll be diving into the mysteries of dark matter and dark energy, the invisible forces that make up most of our universe. We'll be exploring the latest theories and discoveries, and we'll be asking the big questions. What are these mysterious forces? How do they shape our universe? And what do they mean for our understanding of reality? So, if you're ready to join us on this next leg of our cosmic journey, hit that subscribe button and ring the bell to be notified when we drop our next video. And don't forget to share this video with your friends and fellow explorers. The more, the merrier, after all. Together, we'll venture forth into the unknown, guided by curiosity and fueled by wonder. Who knows what we might find? The possibilities are endless, and the adventure is just beginning. See you out there, fellow traveler.